All right, so today I'm going to show you how to make a spinner on your command line on your terminal, and we're going to use bash to do this. Now, in a previous video, I showed how to make a progress bar, and that was really cool. It's a part 1 and a part 2 to that. We get really fancy with it. We animate it. I can put like a little example up here. Progress bars are great. Even if you don't know how long something's going to take, if you know how many items you have to process, say you have to process 50 items and you've processed 20 out of 50, you know you're 40% of the way done, so you can illustrate that visually. A spinner is useful when you don't know how long something's going to take. Maybe I'm talking to some sort of network thing. Maybe I'm talking to some sort of API that I don't have control over. Maybe I'm doing some sort of file system operation that might be instant or it might take up to 10 minutes. Who knows? That's what a spinner is good for. It's just going to animate. It's going to let you know, hey, something's happening. Don't know how long it's going to take, but something's happening, and I can show how to do that in code today. So yeah, let's jump into it. All right, let me give you a quick refresher. If you haven't watched the progress bar video, first of all, what are you doing? Go watch that video. But no, it's okay. I'll show you real quick what we coded in that video. As you can see, there's a progress bar. That's great. We can see what percentage we've calculated. We can see that we've done 10 out of 10 items. We know how many items there are. We know when we're done because we know how many we have to process. The spinner is going to be slightly different, but at the end of this video, we're going to have something similar to this. We're going to have something that animates and runs some sort of function or some sort of command. What the command is itself doesn't really matter. Let's dive into it. Let's start writing some code. All right, so to get started here, we have an empty directory. We're going to make our script, and we're just going to call it spinner. Nothing fancy going on here. Let's go ahead and make our bash script. We put our shebang line in here. If you watch this channel before, you know I write this line a lot. And a lot of people tell me I can automate it. I can put that in a script. I can have something that writes out the file for me. I'm not going to do that. I like making you guys upset. So go ahead and put in the comments if you're getting annoyed by this. So what we can do here is let's go ahead and come up with the animation for a spinner before we even execute any sort of long command. I want to show you guys what's in my brain so you can understand what's happening here. So when I think of a spinner, I think of something like this. I think of, I'm putting a pound sign here so I can just put a comment. I can just put any sort of text here and it won't get executed. Let's think of a spinner as it'll be a slash, it'll be a pipe, it'll be the other slash, and it'll be a hyphen. If we just loop through these characters, it'll look like it's spinning. So we just need to do this in code. So let's go ahead, let's go into our spinner code, and we can do for C in, and then we give it those 4 slashes as strings. So a string of slash, a string of pipe, a string of backslash, and a string of hyphen. So as long as we do this, we should be good. So technically speaking, you don't have to quote all of these. You could probably leave most of them unquoted, but the pipe could be a problem depending on where it shows up in the bash script. The backslash will definitely need to be escaped. If we just quote it, we can ignore any sort of problems with that. So let's echo $C, and let's do done, and let's see what the script actually does. This is very simple, but let's go ahead and run this, and we can see that, okay, it just echoes all 4, and it goes really quickly. Well, we're gonna need to do some things here. Let's slow it down. So we're gonna fork out to an external command called sleep, and we're gonna sleep for 1 second, and then we're going to print it. Okay, this looks pretty cool, but it's probably not what you were picturing. It's probably not what you have in mind, because it emits a new line, and the cursor moves to the next line down here. It's probably not what we want. So let's figure out how to keep it on the same line. Now, we've done this before in the progress bar video, but if you haven't seen it, that's okay. I'm going to show you how we do that. Instead of emitting or using echo, which emits a new line, we're going to use printf, and now we can specify a format string. So the format string will be %s, which means just a string, and the string is $C here, %s, and then we're going to put, what do we need? We need a \r. This is a carriage return. We will put that at the beginning of the string. It's a little confusing if you haven't seen it, but it moves the cursor all the way to the left of the line. Now this is important. The first time we run this, the cursor's all the way to the left anyways, it's not gonna matter, but once we emit that single character, the slash character, then we move the cursor back. I'll show you what this looks like, okay? Because we don't have a new line, I'm gonna go ahead and just emit a new line here when we're done. And just for simplicity's sake, I'm just going to omit the string done here so we can get an idea of when the script's actually done, when it's finished. So let's go ahead and let's run this and see what we get. See what's happening? That's pretty cool. We have a little spinner there. We emit the new line, which moves the cursor down here, and then we emit the string done on its own new line. So that worked. That's awesome. It looks like it's actually spinning. And as you can see, the cursor while it's spinning shows up on the right-hand side because we put the \r at the beginning of the line. So that is pretty cool. But this doesn't do anything. This just runs and it completely blocks us out. It's completely blocking the main form of execution. We've made a fun little animation, but we're not actually executing a command, right? We want to be able to give it some sort of command that it can run and give us a spinner while that command is running. So let me show you what I mean. Let's go ahead and let's make our own command that's going to take a long time to execute. And this is just for an example. You could put any sort of command you wanted here, but let's go ahead and make some command. Let's get really creative with the name. Some really long command. There we go. So this will be a script, and this will just signify that something took a long time to run. So let's go ahead and sleep for, I don't know, 4 seconds. And then let's say echo some really long command finished. There we go. Very simple command. And as you can see, this is just meant to illustrate what it would look like if you were using some sort of command that maybe talk to some sort of network interface or talk to some sort of job server. I don't know what kind of setup you have, but for our sake, we're just going to sleep. So here you go. Look at that. Some really long command finish, and it took a long time. I didn't time it, and I may have even cut the video. So let's go ahead and just put this in front of it just so you can see that I'm not tricking you. We are sleeping for as long as it should be sleeping for, at least 4 seconds. Cool. So let's go back to our spinner code and show how we can use that. Let's go ahead. Now that we're down here and the spinner is done, we can call some really long command, right? And this doesn't do anything at all like we want it to do. We're blocking the main thread of execution. We're animating this spinner, and then we're executing the command. We want the spinner to be animating while we execute the command. We want these two things to be happening at the same time. Now, if you watch my progress bar video, this is in stark contrast to that. In the progress bar video, it was really nice because we could do some work, update the progress bar, do some work, update the progress bar. In this situation, we need two things running at the same time. We need our command to run at the same time, and we need our spinner to run at the same time. Do you see how kind of confusing this can get? So let's go ahead and figure out how we're going to accomplish that. All right, so to do this, we're going to have to do one of two things. There are multiple approaches here. I'm going to just pick one approach and go with it, but I'm going to show kind of what they would both look like. We need the spinner to run, and we need the really long command to run. So we're going to have to put one of those in the background. Technically speaking, we could put both of them in the background and then synchronize. That's more complex than we need to get. We're going to have to put one of these things in the background. So in order to do this, we have our some really long command here. That's really nice. It's defined outside of the script. Let's go ahead and put this in its own little mini program. Now, I've talked about mini programs before on this channel. That's just a fancy name I like to give functions. Functions are like mini programs in Bash. And I go over this all in my Bash course, which is completely free. So if you want to learn Bash and you want to level up your Bash skills, go check out my Bash course. I'll have a link in the description below, and it's completely free. I'm not lying to you, it's completely free. It's not a website where you have to sign up for a free trial or whatever. I'm not trying to get your emails and funnel you anywhere. It's completely free. You can go watch it. It's on YouTube. So that's it. I don't have an official sponsor for this video. I'm just sponsoring it myself. So we just put this in its own little function right here. We should be very good and define our variables as local so they don't bleed into the global scope. We can call spinner here. That's not what I want to write. Spinner. So as long as we put spinner here and then some really long command here, it will work exactly the same how it worked before, which is wrong, but we have at least reduced it down to one line of execution, which is super nice. So we run the spinner, which animates once, and then we wait for some really long command to run, and then it finishes. So again, we have to put one of these things in the background because we need them to run at the same time. So we're going to opt to put the spinner in the background. That's what we're going to do here. So we'll put an ampersand here, and this will put it in the background, meaning it will execute while some really long command is able to execute. So spinner will get thrown in the background, some really long command will get ran, and then we will wait until it's over. So we'll get a spinner going here, but some really long command is still technically running. So look at that. It finished right when the spinner finished. So that's kind of cool. My cursor's on a really weird spot right here. It's not where it should be. It should be up here. That's because we didn't really wait for anything to finish. We put the spinner in the background. The spinner only runs, what, 4 times? And we don't wait for it to finish. So we're going to need to put something here to wait for it to finish. We can do that. We can call wait. Wait is built into Bash, and it will wait for all jobs in the background to finish executing. So as you can see, we waited. Now we got these echoes a little bit out of order, so it's a little bit gnarly here, but we're on the right path. We're coming up with something that kind of works. It's just kind of a mess right now. So let's clean this up. I'm going to do something here. I want to change the sleep of the spinner because it's spinning really slow. It'd be nicer if it spun a little bit faster. Let's change this to we can do 0.1. That's going to be really fast. Let's say 0.2. Now here's the thing. Sleep is an external tool, meaning it is on your system. It's a command on your system. If I were to do, let's say type-a sleep, we can see that it's bin sleep. Technically speaking, sleep does not have to support fractional time specs like this. So 0.2 may or may not work with your version of sleep. I find that it's pretty ubiquitous. I find that it's almost everywhere that it supports this fractional sleep value, but just be aware of that. So technically speaking, this is not completely POSIX compliant, but we're going to go ahead with it because it pretty much works on most systems I've encountered. So let's go ahead and run this and see what happens. So if we run our spinner, okay, that spinner spun a lot faster. And then it stopped spinning, and then we're still waiting for the command to finish. So what can we do here? We don't want this to just spin 4 times and then be done. We kind of want this to spin forever, don't we? Well, we can easily do that with a while true loop. While true, do this, and then done here. So we have our spinner function. It goes into a while true loop, and then it technically has no way of finishing. Because of that, we can get rid of this echo here. It'll never reach it. It can't actually finish it. So what happens when we run this now? Well, we run this. We have our spinner going. Some really long command finished, but the spinner's still running. Do you see the problem? We put wait in there, so I have to control C it to stop it. Because we put wait in there. Okay, so I knew this would be an issue and I was excited to solve it as part of this video, but I didn't expect it to be this ridiculous. Let's go ahead and kill that background job before we do anything. So we're going to PS minus EF and grep for spinner, and we can see that the spinner is running here and it has PID 29559. So let's go ahead and kill. You can't see what I'm typing, but I am typing it 29599. Sorry, I said it wrong. And there we go. Now we've killed it. That's not great. I kind of spoiled something that was going to come later in the video, but here we are. Let's talk about how to fix this, okay? So we call wait down here, which waits for all the background jobs to finish. This is an infinite while loop. This is never actually going to finish. So we want the opposite of wait. We don't actually want to wait for it to finish. We want to kill it. We want to tell it to be done. So how do we do that? We have to get rid of wait first. Now that we've forked off spinner in the background here, we need to store its PID. So spinner PID equals $! This is a variable, it's built into bash, and this means give me the PID of the last process that was put in the background. So we put the spinner task in the background, we get the PID out of it, so we have the process identification for it. We're gonna run some really long command here, and then we are going to kill spinner PID. So that's what's going to happen here. We're going to put the spinner in the background. We're going to run the really long command, and then we're going to kill the spinner. Now this is great because if we run this, it should work how we expect. We got the spinner going. Wait 4 seconds. Some really long command finished, and the spinner's gone. Look at that. That is really awesome. And of course, I kind of spoiled it earlier, but what happens if I'm like, oh, you know what? I didn't mean to run this. Control C. Well, we got the spinner going again, so that's not great. I'm going to pull up a different terminal just to show you guys a different way of solving this. So let's PSEF grep spinner, and we can see that it's running there. Kill 29887. There you go. So now when I go back to the first one, you can see that it's been killed there. All right, so how do we fix that issue? Because we have that spinner that's running in the background, it should get killed here. But if we control this, if we control C the script when we're up here, it never actually gets that kill line. We need this kill line to run when the script exits, regardless of how it exits. So we have to put that in an exit signal. We can do that in bash. So we can trap a signal in bash. So let's trap the name of the function we want to run. We haven't defined this yet. We're calling it cleanup. And we want to trap the exit signal. So let's go here and define our cleanup function. This will run when the program exits. Either it will exit cleanly and get to the bottom of execution, and it'll be the very last thing that runs. So we can actually put done here. This will get run no matter what. So actually, I'll just show it. Because as you can see, we've defined our cleanup function, we trap it, we run all this stuff. If all this works as expected, this done should get printed as the last thing that works. So let's say we run this, we have our spinner going, that's awesome. There we go. Some really long command finished, and then we have done. So our cleanup trap is working. This is really good because once we get down here, we can kill spinner PID, right? Let me go ahead and put that in quotes and put the $ in front of it. We can run this, right? Be a little careful about this because of potential race conditions here. So we trap this signal here, but we don't have spinner PID yet. Spinner PID is not even undefined. Spinner PID may or may not be defined because bash's variable scope is the same as your environment variables. So technically speaking, this could be defined. You can get into some real gnarly situations with this, okay? So what I would recommend you do is we're going to spinner PID equals nothing. We are going to unset the variable. We are going to make sure that it is absolutely, unequivocally set to nothing. When we do that, then we can put a check here. If spinner PID is set to something, that's what -n means here. It means that it is set and it contains something other than the empty string. So as long as this is set to something, then we will kill the process. So This is good because if we were to control C like right after we trap it, but before we forked it in the background, it won't actually try to kill anything because there's nothing to kill. So that's how we're going to accomplish that. Once we do that, we can get rid of this at the bottom of the script. So we don't have to have anything there. We can set our spinner PID to nothing. We can trap the exit signal. Then we fork off our spinner in the background, keep track of its PID, run our really long command, and then at the end of all of it, the spinner PID will get killed if it is set. So if all this works as expected, we should be able to run this and we get a spinner. Hey, that's pretty cool. And it's finished. That's awesome. If we were to control C, the spinner is gone. Look at that. It's not spinning in the background. This is great. Technically speaking, I could still kill -9 this and the spinner would still be running. There's not much you can do. If you kill -9 it, there's not many things I can do there. So just be mindful of that. That's definitely something to be aware of, something to consider. All right, so this is great. But in a more real world example, your command, your some really long command, is probably going to have output, right? In our example, we only have some really long command finish here. Let's go ahead and put something here. We can say some really long command started, or instead, we can just put the PID here. The brackets aren't special. I'm just putting that as a stylistic choice, but we can do $, which is our current PID. And then we can say starting long command. And then we can move this down to the bottom and we can say finished long command. So we can do something like this. And then if we go into our spinner, we can actually do the same thing here. We could say echo $, so we know which command is actually running because the PIDs will be different. Starting spinner. And then down here, we can echo finished spinner. Actually, it's going to make sense to actually put this at the bottom of the cleanup function, and then we can get rid of that done. So I'll take an inventory of what we have so far. So we have our spinner function up here, which is only responsible for outputting the spinner to the screen and nothing else. That is all it does. Then we have our cleanup function, which will kill the spinner if it's running in the background. And no matter what, whether it killed it or not, it will print finished spinner. Down here, we print starting spinner, and that's pretty good. The code's a little bit gnarly right now, but if we run it, take a look at what's going to happen. We have starting spinner, then we have starting long command, and you can see the spinner ran there, and then we finish the spinner. Now notice this is 3144 and this is 3146. The PIDs are different. 3144 is the parent, 3146 is the really long command. So that's really good, but you can notice the spinner kind of shows up here a little bit. Let me change the way the spinner looks just so we can see it more visually. We can do something like this. We could put spaces around it, and we could put like a less than and a greater than around it and a space around it. So I'm just changing how the spinner is going to look. That way, if we run it, you can see, okay, it's still spinning, but we have this like weird kind of output showing up there, but it makes it easier to see. So the spinner finished, but we didn't do anything like clear it out or anything like that. So this is good, but here's a cool thing we can do. We could put the spinner, instead of the \r here, we could move this \r to the end. So we can move the cursor to the beginning of the line after the spinner has been rendered. I'll show you why you'd want to do that, because if we run it, take a look at this. We have the spinner running, and then the spinner's gone. Look at that. We completely clear the spinner out of the output. How cool is that? So we just have our output here. We have our spinner letting us know, hey, something's progressing, but then when there's new output, it gets completely wiped out. We can see the parent says starting spinner, the child says starting long command, finish long command, and the parent says finish spinner. So that makes sense. This life cycle is starting to make sense, which is really cool. Okay, so what's next? Well, let's talk about some really long command. We sleep for 4 seconds and we print at the top and we print at the bottom. Okay, that's pretty cool. What if this command were a little bit more involved? So what I mean by that is, instead of sleeping for 4 seconds, what if it did something like this? What if it said for I in 1.4? So we're going to count up from 1 all the way to 4 inclusively. What if we were to sleep for 1 second, and then up here we were to echo the same kind of thing we've been echoing before, $$ for our PID, finished I out of 4 ticks. So it still sleeps for 4 seconds. Let's go ahead and trash all these. It still sleeps for 4 seconds, but what it does is every second it prints like this to the screen. So if we look at the source code for that, we can see it here. Let's go ahead, I'll pull up the source code and I'll run the spinner and we can get an idea of what's going on here. Okay, so that's great. This works exactly how we wanted it to work. We have the spinner working, and the spinner gets completely cleared out whenever the long command emits any sort of output to the screen. That's super cool. That is what we want. So let's actually make this useful, okay? because we have our spinner here. Look at this. We have our spinner function here, which actually, forks the task in the background to animate it. We have our cleanup function here, and then we have the spinner pit and everything. This thing right here is the command we're running. Now, that's really great that we're just running our own hard-coded command, but what if we wanted the user to give us a command? Well, we could do that really easily with this. We can just put $@ in quotes. This is valid syntax. I am not lying to you. This will take the arguments that the user has given us, and it will just run it like a command, properly broken up into multiple arguments, which is super great. All right, so that's some odd syntax. I'll show you the source code. We'll pull it up. You can see, I want it to be at the bottom. Is there a way to do bat with no pager? Please be minus capital P. I'm awesome. Oh my God, look at that. I'm great. Okay, so as you can see, yeah, we just called this all the way at the bottom. So if we run spinner and then we give it some really long command as the argument, it should fork out to the some really long command. And it does. That's super great. We could also call, I don't know, sleep 3 here. And it will execute sleep 3. We could call something that doesn't take that long. We could call uname. And it returns almost immediately and runs the uname command. We have built a wrapper for whatever command we want to give it that forks out a spinner for us. What if we give it nothing? Well, doesn't do anything. Doesn't do anything for us. So that's not great. Don't give it no arguments. In fact, I would even check the number of arguments here. I would say there's a couple different ways to check it. I would say $, which is the number of arguments there are. If $, equals 0, then echo some sort of usage message. So I could say like usage spinner command like that. We can output that to standard error, exit with a 1, close the if statement, and then run it down here. So once we get to this line, we know that some arguments have been set. So now we have this. We could run spinner on its own, and we can see that we get this. This is probably a little bit confusing to you guys because you're like, wait, what happened? I thought it was supposed to break. Well, it did technically, but because it already trapped the cleanup signal, we got all this stuff. So if we're going to make this a proper program, we kind of have to change a little bit of the life cycle down here, okay? Now, to do this, to clean things up, I'm going to go ahead and opt for a main function. If we make a main function, it'll make it a lot easier to understand what's going on. Now we can move everything over here. We can close the main function, and then we will call the main function with the arguments that the user gave us. So we haven't changed much. We've just declared a main function. We do have a global variable here of spinner PID. So I would go ahead and set this up here just because we want this to be completely upset for the entire program. And this is going to be global. This variable is used by other functions. So we'll set it up here. Now we have a global variable set to that. And then we trap the cleanup here before we even check the arguments. We can do things in a different order. That's basically what we have to do here. So we'll move this logic to the top of the main function. If the number of arguments is 0, then we will just output a simple usage message to standard error, and then we will exit with 1. We can change this from an exit to a return because we'll just return from the function, and the error or the return code will get captured by this call. And then we can actually start trapping our cleanup signals and doing some sort of work and starting like that. So we just move things around. We put them in a function so they're easier to understand. Now we run this without an argument. We just get the usage message, and we also get a failure exit code, which is good. But then we can give it a command like uptime, and there we go. Starting spinner. My computer's been up for this long, and then we finish spinner. Now again, that command doesn't take that long to run, so let's give it a command that actually takes some time, like sleep 3. And there we go. There's our spinner. So what are some more modifications we can do this? Well, I'm gonna be honest. Spinner's a little bit ugly, so let's come up with a more fun spinner. So let's go up here, and we can see that we have our characters here, and we sleep for 0.2, and then we print them out like this. Let's go ahead and make an array of characters. So we can do chars equal this, open and close parentheses, how you make an array in bash, and now any elements we give here will get used. So our spinner's going counterclockwise. Let's make it go clockwise. Let's make it go backwards. So we'll put the backslash here, and then the pipe, and then the regular slash, and then the hyphen. Now, if you wanted to, you could put these on separate lines if this makes it easier to see. It's totally up to you. But I'm going to put them here, and then we will loop over them. So we have to quote this, chars, open and close the square brackets, put the @ sign in there, and there we go. Now we're looping over the characters. And if we do it that way, we can move this like that. We can kind of clean up that printf. So now if we run this with the spinner of sleep 3, we can see that the spinner's going. The cursor is a little bit on top of it, which is kind of ugly. I don't like it. So maybe I would put a space here. It's still going to have the same problem because of the backslash. So yeah, I'm just going to surround this thing in spaces just so we can kind of see it. Again, you can kind of put the spinner wherever you think makes the most sense. So we are just pushed over one from the left, and it still gets eaten by whatever output comes after it, which is super nice. That's kind of great. So the nice thing is we could put anything here. They don't have to be a single character. So what I mean by that is we could do something like this. We could put like greater than ... And then down here, we could do something like dot greater than ... And then ... greater than ... And then there's all sorts of fun stuff. There's Unicode characters, there's Braille characters. We could do all sorts of fun stuff. You can kind of see what's going on here. If we run this, now we have that. That's kind of cute. That's kind of fun. You feel free to mess around with this, come up with whatever things you think make sense. You could colorize this if you wanted to. There's really no rules about it. You just come up with whatever animation you think looks nice. And the beautiful thing is, if we run that command that kind of outputs over time, we can see that it eats up the line just fine. That is kind of what we wanted here. We could get rid of this debug output if we wanted to. I'm going to get to that in a second, but I think if we're going to clean this up a little bit more, because right now we have our standalone spinner program, that's pretty cool. I want to do something I haven't really done on this channel yet, but I want to show how to like clean this up and really make it a full-fledged command. Because a lot of times I show you guys like, prototypes or sort of how to get started, and I like that. I want to encourage you guys to sit down at the terminal and code this stuff yourself. But let me show you how I would actually clean this up, how I would make this like a full program. So let's go ahead and do that now. The first thing I would do, if I were looking at this script, I'd be like, okay, we have a usage message here, but this could be better, right? This could absolutely be better. So let's go ahead and define a function called usage, and this will just print the usage message to the screen. We can do that using a here doc with bash. So now anything in here will get printed to the screen. So we could say usage spinner, which is the name of the program, command, and then we could do like args ... or something like that. But I'm going to do this. I'm going to say options here, and we're going to add some command line options. We haven't gotten there yet. Before we continue though, look at this. I hard-coded spinner. You don't need to do that. We can get the program name from $0, and we can take the base name of it. So #/# greedily find and delete from the left * anything / up to the first literal / character. From the left of the string, we'll delete everything up till the last / character, and we will retain everything to the right of it. That will give us the base name of the executing program. So we'll just put prog here. And there we go. Now we have a usage function. We're going to add more to it, but let's swap out things to use this usage function, because this can just be usage. So if that works how we expected, I should just be able to run spinner with no arguments, and we should get that usage message. Hey, that's awesome. So let's go here and make this a little bit better. Run a command with an animated spinner at the front of it. No, I don't like that. That's too verbose. Run a command with an animated spinner. Hey, simple enough. That's awesome. Now, do we want to take any sort of options? Because we definitely could. We could take some sort of customizable options for this. What kind of options would we actually take? Well, I think the obvious one is that we have these debug outputs here, starting spinner, finish spinner. That seems excessive. We probably don't need them, but it might be useful to someone in the future that cares about it. We could hide that behind a debug flag. So let's go ahead and just imagine some options here. So options will be enable debug output -h, print this message and exit. Hey, look at this. We're already getting some good options there. So let's go ahead and implement these options. Now we are in a function here and we're checking the options here. Here's what we can do here. We can do while getops for getting options in bash. The two options we defined are D and H. They both don't take values. They're both Boolean flags. So we don't put a colon after them, and we can just call it opt. That's the name of the variable we're going to use. So now we can do a case statement over opt in, and these are the two options that we could possibly have. D for debug, where we could say debug equals true. And then we could say H, which just prints the usage message and then exits with a successful code. Star means that we got something we didn't expect. So we'll still give a usage message, but we'll write that to standard error and we will return with a failure code here because something failed to run. Now we can do done here. And now we still need to be able to get the arguments out of it. So we have to shift by opt-in, which is the index of the option, -1. So once we do this, now let's imagine that we were called with options like, let's imagine we were called with this, spinner -d sleep 4 or sleep 5. So in this example, once we shift, we'll be left with sleep 5, which is good. Once we're left with that option, then we can just treat that like the command that we need to execute. So that's what that shift accomplishes. Now we are in a function, so we have to do some things here. We have to declare opt as local. We also have opt-in and opt-arg. You want to declare these as local because this will reset the internal state of getOps, so just kind of commit that to memory. But if this all works how we expect it, then we should have a working -h. It still just prints the usage message, but we have a success error code. If we omit the -h, then we should have a failure error code. So hey, that's awesome. We are making something official here. So let's go back up here, and we have debug equals true. That's awesome. We haven't defined anywhere. Let's do debug equals false. And we are defining these as global variables, so let's just go ahead and take the spinner PID and make that all uppercase, just to match the style that we have here. So where do we call it? Here and here. Yeah, that works. Oh, we also use it down here. Okay, we use it in more places than I remember. Cool, so now they're all just uppercase. No big changes there. But what we can do here is when we want to print something like this, which is a debug line, we could check if debug is set to true or false. We could also put it in a function. So we could make a debug function that checks if, let's see, debug equal true. Now, we don't technically have booleans in bash. There are some ways we can get around it. So we can treat it like a string and just compare it this way. There are some other things I've seen set that I like. So we have debug equals false and debug equals true down here. Technically speaking, those are both commands. And they're not taken by the user. They are controlled by us, the programmer. So according to my style guide, and what I like to do is to just treat them like commands. If debug, then let's echo whatever the user gave us with the PID in front of it. Let's echo whatever the user gave us, stringified, and let's write that to standard error. There we go, but only if debug is set. So actually, yeah, I think it's all caps. There we go. So if debug is set, so if it's set to true, then that if statement will be true. If it's set to false, then the if statement will be false and won't actually work. If it was set to anything else, we're running a command. That's not great, but as long as we, the programmer, are controlling this variable and we're never taking it from the user, we're safe to do it this way. This is how I do it. I might be changing the style in the future, but for now, this is how I do it. So this allows us to kind of have booleans in bash in a way. So now we have a debug function, which will just print whatever arguments we gave it with the PID to standard error. So we just swap this out. You ready for this? Put debug here. There we go. We can get rid of that because we put that in the function itself. Finished spinner. Cool. So now down here, we can have our, what was it? Debug starting spinner. And we could even do something like this, like debug spinner PID equals spinner PID. Now you have to put that in double quotes because we actually want that to expand. And there we go. There's our command now. All right, now it might be a little bit weird because it still has the brackets with the PID in it, and it kind of looks like our debug output. Technically, it's different. Technically, it's just part of this command. If we were to go ahead and get rid of it like that and then rerun it, you can see like, okay, cool. We're not actually getting any sort of debug output. It doesn't look like debug output. If we were to rerun this with a -D, now we have turned debug output on. We can see the spinner has started, the spinner PID is this, and the finished spinner. We could even do something like in our spinner, we could go up here to where we kill it, and we could debug killing spinner PID. You could do something like that if you wanted to. This would be useful for like development work and stuff if I were to plan on adding to it. Now, I think one of the next things we could implement would be like a theme, different sort of spinner characters. Technically speaking, we could allow the user to just give us a series of characters and we could loop through them one by one so they can kind of make their own spinner. Or we could have themes where we just kind of hard code a couple of different ones. I would go either way on this one. I don't really care one or the other. I think for this video, it might be more fun to do themes and come up with just sort of different examples we can use. So let me go ahead and pull this up. I found this project, which is really cool. I was looking through GitHub, doing some searching, and we got this nice little CLI spinners repository here. And what I really like about it is there's 70 plus spinners for use in the terminal. What I really like is that the list of spinners is just a JSON file and can be used wherever. So that is super nice. And you can see, check it out over here, MIT license. So super nice. We could pull on the source code, we could put proper attribution, and we can use some of these spinners. So yeah, I guess let's just jump into it. Let's see. We have the JSON file here. Let's go ahead and pull the raw file. Grab this, pop over to our terminal, and we can just wget this. So now we have spinners.json. So that's our program. Spinners.json. There we go. Oh boy. Okay, this will be fun. Let's pipe this to JQ, actually parse the JSON a little bit. And we have a lot of different options to mess with. I don't know if we're going to implement all of these. Technically speaking, we could. It'd be kind of a gnarly file at the end of it. So yeah, let's grab the first one here. We got dots. So dots.frames, and that'll be that. So dots.frames, and now we have that. Let's go ahead and get the raw output of that with this notation to loop over each one of the array. Now we have all of the characters separated by new lines, which, hey, that's pretty good. So yeah, we can literally just take this and we can go into our script here. So we have our spinner script here, and we can come up with a theme variable. So -t will be theme. And now we just need to come up with different themes for them. So let's go ahead and change this around. Let's say theme to use default is $theme. We'll define that later. Like an LLM, we're just hallucinating variables and functions, and then we define them as we need them. So the theme will be default. And then when we take the theme parameter from the user, t:, because we're taking something from them, t is this, theme equals opt_arg, and then the double semicolon to close that. So now we can, based on the theme, we can go and figure out what to actually give the user here. So there's a couple ways to handle this. What I think is the simplest is to just come up with a global variable called chars. We could define this in the function. It wouldn't actually matter where we put this definition, but I'll show you why I like this one here. We can come up with a function called load theme. So we could have load theme, and load theme will take the theme name as an argument, and then we can just do a whole case statement on it. So case theme in, and then here's our theme. So if it's a default theme, then what we will do is we will say chars, which is that global variable that we defined up here. We can say chars equals, and then we can set what is supposed to be there as an array. So we make an array here, and we can give it what the default theme is. Now, the default theme will just be the slash, the pipe, the other slash, and the hyphen. So that's it. That's what the default theme looks like. We can do this. Dots was the name of the theme from the other one. So we can do dots equals this. And then we have all those pasted on our clipboard, and we can do this. Now, let's go ahead and fix some formatting a little bit. Technically speaking, we can put them all on the same line, and they don't have to have string quotes around them. This should be valid. Now we can just do one last thing here, and we can say echo invalid theme, write that to standard error, and then print the usage message also to standard error, and then exit with 1. So there was a failure there. So we can do it like this. This is kind of how you would format it. So now we have our load theme function, which will take the theme as an argument. So once we get down here, we're going to want to load the theme of whatever the user has given us. And then that will load the chars array for us. So then when we go up to the spinner here, instead of defining it here, we can just do this, for c in chars. There we go. So now if we go ahead and we run this, I think I did everything right. We could do spinner with some really long command, and we have the default theme running. All right, that's pretty cool. So now if we go back here and we do -t dots, I think was the name. Look at that. Now we have the Braille spinner running. How cool is that? If we give it something like bad theme, then we get an invalid theme. So that's pretty awesome. That is pretty cool, actually. So yeah, so now it would just be a matter of just implementing more themes. I'll do a couple more just because they're kind of fun, and I can just show you how to actually make it work. What kind of themes do we have, actually? Let's go ahead and look through this together. That's a gnarly one. This is insane. Some of these are crazy, dude. I love the emoji ones. I mean, I feel like we got to use one of these crazy ones, right? Like, these just seem like way too cool. Let's go ahead and grab this one. This one's called Pong. I don't know how this one's going to look, but I think it'll make the video fun. .pong, and then I think it's .frames. There we go. So let's go ahead. We have this. This is the whole entire thing we need. This is going to be pretty gnarly. I might end up taking this. We'll see if this even makes the final video. Let's go here and let's do Pong. Is that chars equals this. Let's go ahead and just put this in the chars array. There we go. Now we don't need these commas. In fact, it would actually just put a literal comma character there. So we get rid of those commas, and let's go ahead and close the chars array. This is wild. Oh man, this is really funny. So let's go ahead and run this with the Pong theme and see what happens. So what is it? This. Go and give it Pong. Oh, that is cute. Oh man, okay, it's not running fast enough. I'm sure I could reduce the sleep for it. Let's go ahead and sleep 60 just so it'll run for a long time. Look at that. That is cute. I like that. That's really fun. All right, that's beautiful. I think that's gonna make the video because that's super fun. Let's go up here. That's a lot of the code right here. All right, so what's one of the last things I would do? One of the last things I would do would be to just put some metadata up here. So let's say, run a command with an animated spinner, and then we can go ahead and put some licensing information. I have a little macro set up for me, so we run that. That's awesome. And now we have the date and my email address. That's awesome. We could put more information. We could say spinners taken from, and then we can put a link to the CLI spinners repo there, which is super nice. So yeah, there we go. I think this program is pretty much done. There's not much else to add to it. We have a nice little usage message here. We can just run it with a command. We can just run it with like uname, and it just works. And we can give it a debug output. Now we have that. That's awesome. We can give it a different theme of dots, and it doesn't matter because that command doesn't take a long time to run, but sleep 20 would. So we get the nice little dots output. That's super nice. Control C properly kills the background job. So yeah, I think we've handled all of the edge cases here, really. Cool. So again, one last thing to keep in mind, just to be aware of, is that these fractional sleep thing, like I said, this is technically not POSIX, so this may not work on your system. Most systems I've encountered will be just okay with a fractional sleep. Technically speaking, if your version of bash ships with it, there is a sleep built in. So if you were to run type-a on sleep, you can see that it is just bin sleep. If I were to enable sleep and then rerun it again, we can see that sleep is a shell built in. Now we have the built-in version of sleep, which does support a fractional specified period, which is super nice. That's super awesome. Your version may or may not ship with it. So something to keep in mind, definitely something to be aware of there. And yeah, there we go. There's our spinner command. It works. It takes arguments. It has a help message. That's super nice. I'll make all this code available online because I know people want to rip through it. And yeah, I think that's about it here. Thank you everyone for watching, and of course I want to give a shout out to my patrons over at Patreon. Thank you so much for your continued support. Look how many patrons I have. I'm filling up a whole terminal with 4 different columns each. So thank you everyone for checking it out. Thank you everyone who's signed up for my Patreon after my bash course came out. I got a lot of people since then, and I really appreciate that. I think that's awesome. If you haven't checked out the bash course, go check it out. It's over 7 hours of content just on bash, and it's just me yapping for a while. So ton of fun. Thank you everyone for the support. Hope you appreciated this video, and yeah, have a good one. See ya. Even if you don't know timing, if you know that you're processing 100 items, divide that by 100 and you get 1.